So we are going to talk about another transformation today. I don't think today is like quite as easy as yesterday, but it's not. If it's harder at all, it's not much harder. So we are going to talk about reflections today. So a reflection across line M, so it's kind of referring down here to this picture so you can see line M. So if you were to take this triangle and reflect it across line M is called the line of reflection. Okay, so if you reflect a figure across a line, it has the following properties. Okay, first of all, if you have point A, so like in this picture, point A is right here. Point A is on the line of reflection. So if you were to reflect point A across line M, but point A is on line M, the reflection, the image, and the pre-image is the same thing. They're not going to move. Okay? I kind of think about a reflection, it's almost like you just flip it over the line. And so if it's on the line, it's not going to move. It's going to be in the same spot. Now, if you have points that are not on the line, which is usually more the case, like point B right here. Okay, so what you're going to do, in order to reflect point B across line M, okay, it says that line M is the perpendicular bisector of the segment BB prime. Here's what that means. If you go to B and go straight to line M, and you remember that the shortest distance between a point and a line is a perpendicular line, okay? If you go from point B straight to line M, that distance, like, let's say it's 3, okay? The reflection of B is going to be on the other side of M, that same distance. So straight out, that would also be 3 inches, feet, whatever it happens to be. But that's how you're going to do a reflection. You're going to go straight to the line of reflection and then to the other side that same distance. So line M is the perpendicular because you have to go straight to the line. And it's a bisector because you have to go the same distance here as you do on the other side. Okay, but in order to reflect points or figures, which is what we're going to do today, go straight to the line and then that same distance on the other side. Okay, and then the notation that we're going to talk about today, similar to yesterday, it's going to be function notation. Yesterday we used a capital T for translation, and then down here was our rule, and it had the little like arrow things, and it told you how to translate it left or right. Down here is still going to be your rule. It's going to look a little different. Down here is the line of reflection. So this is a reflection across line M of point P would be P prime. Okay, and so whenever you have some properties of reflections, reflections are going to preserve distance, which just means between these 2 points, it's going to be the same in the reflection between those same 2 points. Works for all of them. And they also preserve angle measures, which means from yesterday, if something preserves distance and angle measures, what do we call it? Rigid motion. Rigid motion. Okay? And then, since it's a function, the reflection is going to map each point to one and only one corresponding point of the image. Okay, so what we're going to do first is we are going to practice reflecting some points. So for the first one, we want to find the coordinates of each image. So once again, kind of hitting back on that notation here. We have the reflection. Okay, this down here is the line of reflection. So my line of reflection here is the x-axis. So I like to, if I have the graph, I like to actually draw the line of reflection because I think sometimes it helps being able to see that. So for this one, I'm going to reflect it over that line. And we are going to reflect point A. Okay, as a reminder, how you are going to reflect points, which is then going to let you reflect an image, you're going to take the point and you're going to go straight down to the line of reflection. So it's nice whenever your line of reflection is a horizontal or vertical line, which most of the ones today are. Because if my line of reflection is a horizontal line, if I go straight down to that, it's going to be a vertical line. Okay? So if I go from A straight down to the line of reflection, that's 2 units. To reflect point A, I go straight down to the line of reflection 2 units. The reflection is going to be straight down 2 more units. That's going to be A prime. Which the coordinates of A prime would be 4, negative 2. Okay, going back to this one, we want the reflection across the line y equals -1 of point C. Now, like I said, I like to actually draw my line of reflection. I think sometimes that helps. So I'm supposed to reflect across the line y equals 1. Those who had me last year hopefully remember. What does a y-only line look like? Y, yeah. Y, yeah. Okay, yeah. So this is going to be a horizontal line through y equals 1. That's the line I'm going to reflect C across. So I'm going to go from C straight to the line of reflection, which is 2 again. And then I'm going to go from the line of reflection down to more. That's C prime. That's C prime right there. At -2, -1. And then for the third one, we are going to reflect across the line x equals -2, and we are going to reflect point F. What does an x-only line look like? X like an X, right? So x equals -2 is going to be over here. So for this one, you're going to take that point straight over to the line of reflection. So this time I'm moving horizontally. So if I go left, 1, 2, 3, 4 units to reflect point F, I need to go left 4 more units. F prime would be over there on the edge, which would be at -6, 3. So that's how you reflect points. We use this idea of reflecting points to reflect an image. So down here, we're going to have 2 graphs. We're going to use the same triangle. So we are going to give the points S at 1, -2. We go ahead and graph that, 1, -2. T at 4, -1. And V at 4, -4. We've got our triangle. So we want to graph triangle STV, and then we want to graph its reflection. So for this first one here, we want to reflect across the x-axis. Once again, it's not required, but I like to draw the line of reflection. I think it helps being able to see it. So to reflect triangle STV, you are going to reflect S across the x-axis, you're going to reflect T across the x-axis, and you're going to reflect V across the x-axis. So if I start with S, we're going to go straight up to the line of reflection. So I went up 2. So for S prime, we're going to go up 2 more and put S prime. For T, we're just going to go up 1. So for T prime, go up 1 more. And for V, I go up 1, 2, 3, 4. So we're going to go up 4 more. 1, 2, 3, 4. For V prime. And there's the reflection. Okay, for the second one, we're going to reflect the same triangle. So S at 1, -2. T at 4, -1. And then V at 4, -4. And this time we are going to reflect across the line x equals -1. What does an x only line look like? Good, x like in ax. So over here at -1, that's my line of reflection. So if I start by reflecting point S, if I go left 2 to get to the line of reflection, we need to go left 2 more for S prime. For T, we're going to go left 1, 2, 3, 4, 5. So that I would need to go all the way 1, 2, 3, 4, 5 for T prime. And you can notice that V is on that same vertical line as T. So V prime will be right below that as well. And we have our reflection. All right, let's get this glued into page 83. This is 9-2, reflections. So we're going to do 2 examples with this same triangle. So we're going to have point X at -4, 3, Y at 2, 6, and Z at -1, -8. We'll do 2 examples with the same triangle. If you would like to, you can just do it on the same graph. Maybe use different colors for each one, maybe, if you have it. But let's go ahead and let's plot. Let's draw triangle XYZ. You might just do, whenever you're setting up your graph, to 10 spots to the left, 10 spots to the right, and then 10 up and 10 down. Like I said, we're going to do 2 examples, but we can put them both on the same graph. Okay, so if we plot our 3 points, we have X at -4, 3. And make sure you label your points. Draw it on here. Y at 2, 6. And Z at -1, -8. And it's a triangle, so we'll go ahead and connect those. There's one everywhere.
Oh yeah. You're right.
-1, negative. Thank you. Okay, number 1. We want to reflect across the x-axis triangle ABC. So remember that notation there. We're going to reflect across the rule is the x-axis. Now the other 2 that we did, it reflected, and you could actually really think about just taking it, like flipping it over and creating a new image. But if you notice on this one, whenever I reflect across the x-axis, it's going to reflect kind of inside itself in a way, but you can still think of the same thing. Basically what you're going to do is if this was like a 3-dimensional thing, and you had this on like a pole, okay, or a stick, and you just flipped it, that's what we're doing here. That's what it's going to be to reflect this. So in order to reflect triangle, it's not ABC. It is XYZ. So in order to reflect triangle XYZ, we need to reflect X, Y, and Z across the x-axis. So if I start with X, we're reflecting across the x-axis. So I would go down 3 units. So for X prime, I'm going to go down 3 more. There's my x prime. To reflect y, I would go down 6 units. So I would need to go down 6 more for my y prime. And for z, this one I need to go up 8 units. So I'm going to go up 8 more for my z prime. And then we should have our reflected triangle. Which, notice with a little imagination here, you could think if you just flip that down, should look pretty similar to that. Okay, we'll just draw the second reflection on this same graph. We're going to flip it over the other way. If you'd rather draw it again, you can. But for number 2, we are going to reflect across the line x equals 2 triangle x, y, z. Not A, B, C, triangle x, y, z. So first thing, I like to draw my line of reflection. What does an x only line look like? X like x. So it'll be right here. Now this time, to plot x prime, we need to go from x all the way over here to my line x equals 2. So if x is at -4, when I get to 0 and then even over to 2, another 2, right, would be 6, right? 4, 2 would be 6. So I need to go out 6 more, which should give me x prime over there at 8, 3. Y, now let's look at y. Because I'm supposed to reflect y to y prime, but y is on the line of reflection. It stays in the same spot. Yep. If your point is on the line of reflection, just think about it. It would just stay in the same spot. It wouldn't move. And then for z, we're going to go over 3. It looks like more than 3 because my graph wasn't perfect. But then if I go over 3 more, we'd have z prime about right there. That one was not a very good graph. Okay, there's other things that you're going to be doing in your homework, but it was kind of hard to come up with examples for them. So I've got one more thing for us to talk over, and then I'm going to give you guys more time to work on your homework. So, as best you can, try to sketch this out. I thought it would be better for me to just copy the picture instead of trying to draw, and then you guys will just have to try to draw it. So, we're going to have line M right here, and then a diagonal line K. And it doesn't have to be perfect, but you should have triangles 1 and 3, 1, 2, 3, 4. Okay, make sure you number them. Like I said, they don't have to be perfect, but just try to get them as close as you can. So I'll give you about a minute to try to sketch that out. So you're going to have one super similar to this in your homework. So what we want to do, it says each triangle is a reflection. We want to write a reflection rule. Okay? So what I'm going to do is I'm going to give you a triangle. I want to know what rule would give me that triangle. So in other words, I kind of gave you the answer. We want to come up with what would the question be to give me that triangle. So if I wanted triangle 2, I want to write a reflection rule. So kind of two parts in this. Number one, you have to decide which triangle you're going to reflect. But you also have to decide what my line of reflection is. Those are the two things that you need in a reflection rule. It's going to be the big R, but then I need the line of reflection, and then I need what triangle we're reflecting. So, if I want the answer is triangle 2, what triangle could I reflect and get triangle 2? I think 4, right? Because if you look at 3, if you were to reflect 3, I mean, it has to be across line M. This flat side here would be in over here. That one wouldn't work. And triangle 1 would be up here. So it'd have to be triangle 4. Triangle 4. And what line would you reflect it over? Okay. Now to show you, remember that if I reflect triangle 4 to get triangle 2, it means that K should be the perpendicular bisector of each of these. So if you were to draw a line from there to there, perpendicular, looks like a bisector. If I were to draw a line from here to here, that's perpendicular line, and it looks to be about the same. And then same thing, from here to here, perpendicular line, it's a bisector. Okay? And what if I wanted triangle 3? Okay, we want to reflect to get triangle 3. What triangle would you reflect? Triangle 1 across what line? And remember, that's the rule that goes right there.